these DC to DC boost converters. I I've had mine for a while. I fried mine about 2 months ago, plugging in. Hold on, um, one of these scooter controllers. It just draws so much current in the thing. It has 60 I believe 60 actually 90 or 60 amps of fusible safety. Um, it's the 1800 uh, uh, 0 to 90 volt DC boost converter with the adjustable current, adjustable output and input. Um, so, I really was just gonna buy another one, and then I tinker with electronics. I like to get down to the component level. Um, so, sorry, I'm not really very organized right now, but I just want to shine a light on a few things. So anyway, um, so there was a guy that did a current test, a full load on this, and the thing, maxed out about 320 watts. When you buy them, this is rated for 1800, um, and it was only pulling about 20 amps. And the fuses, there's 320 amp fuses. This is the bigger one you can get. Most people get the one that's only the 40 amp fuse, but I guess it really doesn't matter because it's not really going to handle that. And I um, I normally, I'm one of those guys that, I've been working in electronics off and on for a long, long, long time since I'm 40 now, since I was, I don't know, 10, 11. Just to give a little background, um, I went to a tech school. I didn't go to a college or anything, so I have a little bit of background. I study up. I read a lot of textbooks. But anyway, so I know the fundamentals. I know how digital circuits work. So I have a pretty good grasp of how things work. Well, anyway, you know, this thing was, I don't know, $18, dirt cheap. Um, and obviously you get what you pay for on eBay or where, I got it on eBay, but wherever you get stuff, just like these guys right here, these are the IRF 3205s. They can handle 55 volts, um, supposedly 190 amps or whatever. Um, I just found out the other day they're not the real ones, and I only paid $10 for 10 of them, so it was like $1 a piece. But I did check them. I did the whole run a light bulb on one side and then tap the two leads and got them to all come on. They weren't all exactly the same. They range from like 0.11 volts to 0.08 volts. But anyway, so back to my whole thing here. So I thought to myself, I wonder if I can fix this and make it better. Um, I'm just checking. I don't have a load right now, but I just want to see if anything's getting hot. Nope. Anyway, so I want to see if I could, the fundamental here, basically it's an inductor um, with a diode and a capacitor and a switch. And mainly the diode, I want to say the diode is what goes bad on most of these. And the diode is the part that they don't fully they straight lie when they say 1800 watts, because the diodes that were in there, I believe there are 2100 CTs, which are 20 amps max. So you have two of them in parallel, so that's 40 amps. But if you want to push it, they're going to pop. And if you have a surge, they're going to pop. Because I don't think there's any surge protection here, obviously, because I blew the main MOSFET and I blew one of the I believe they're I don't know the technical name, but they're two diodes, and I believe they're in parallel packaged as they look like a transistor. You have an anode and a cathode. You have two anodes and one cathode, I believe, something like that. But anyway, so I noticed that the weak link was the diodes, because the transistor was good all the way up to I don't know, 120 amps, which, you know, I'm not gonna pull that much. I'm just using this for a electric scooter. So anyway, so I had a old it wasn't old, but a a boat. I used to work as a boat mechanic, so I used to have I had all kinds of charging stuff for marine batteries, deep cycle batteries. Anyway, I had this blown up charger. I believe a couple of MOSFETs were shot, but I like to, you know, salvage parts from that. So they had you could have up to 4 batteries, and they had these big um, diodes on. Which actually, here's one right here. And these guys, I think they can handle up to like at least over 100 amps of current. These guys right here, and they, you know, the ones that were with this are like couldn't even lay a flame to this. So I was like, wow. So I checked them all, make sure, you know, between each terminal, they, you know, only read one way, because, you know, that's how a diode only allows current to flow one way. It's like a check valve. But it's so I was like, wow, imagine if I could get these guys to work with this. It would quadruple the current rating. I would never go past even close to the current rating that these are at now, right? But I also had an issue with the MOSFET. I couldn't find anything, because that MOSFET was 120 volts, 190 amps, I believe 30 volt source to gate, gate to source, or whatever it was. Which my real main thing was I wanted to make sure that my voltage was around what I wanted on my output, because my output, I wanted 48 volts, and I wanted to be able to put 12 or 24 in, you know, and get 48 on the other end to power a treadmill motor. Which, anyway, so I had some of these IRF 3205s. Which, here, I'll get one. I had a bunch. Like I said, these weren't the real ones. These were the fake ones. So that in mind, all these guys right here. I had bought these a while ago, and you know, the current rating is really high on them. But then I was told, you know, these weren't the real ones. And so basically, to make a real one, I had to run. I figured I'd run 4 in parallel, so I quadrupled the current. So if, you know, one was like not, you know, one was only 50 amps and the other one, anyway, in my mind I felt like it had to equal it out. So I ran 4 of these clone IRF 3205s, switching MOSFETs. They are the enhanced channel ones, N channel, so they run on the negative side of your circuit. I put them on a separate heatsink, because if you have this, you know, there's not really any room. And yeah, I probably could have put them onto that, but this is a work in progress. For some reason, when this is mounted to that, my power supply starts going up in current. So something's, you know, this doesn't like to be connected to that. So I isolated it, and it works fine. I put some ferrous, I guess you'd call it, rings between the gate, the center pin on all 4 of them, just because they create, you know, quite a bit of magnetic field. So anyway, just to be safe, not that you know, I don't think it's going to be drawing that much current, but then I wanted to add more cooling, so I have this fan here, but I'm going to put another fan on the opposite side right here, so it pulls the air out too. But now I got to rethink where I'm going to mount these guys. But just to show you that it is